Thank you for purchasing a Viking Aircraft engine. This is a tutorial on the wiring of the Viking 130 aircraft engine. What we've got in front of us here is a wire diagram as made for the installation of the engine in a typical aircraft. The basic components that are needed is a battery, preferably 2 batteries. What's inside this dashed line is the backup battery that we highly recommend. If you have a gyrocopter or an ultralight and you're kind of just flying locally and you're never really going far away from home, then maybe 1 battery and the alternator is all you need. But if you're going any kind of distance, it's very important to consider the backup section here in order to be able to add electrical current to your system in the event that the alternator goes down. Now you're working on just 1 battery, and when it dies, depending on how far you have to fly, or if it took a while before you caught the fact that the alternator had died and the battery is being discharged, you could then go to your backup battery. We also have some contactors that are, all these components, by the way, are available on the shopping cart at Viking to help you have concise and easy access to parts and consistency between one airplane and another using the Viking engine. So we talked about you need 2 batteries. We have some contactors here. These are battery contactors to turn your batteries on and off. There's also one for the backup battery. As you notice, they both end up going into the same junction right here, which means this is a complete standby. There's no fancy electronics to charge the backup battery. You're basically using 1 battery or the other battery feeding the same junction to power all these items that are necessary to keep the engine running. In addition to that, there's a couple of diodes here. These are wired across the contactors, and then there's a switch going to ground to close the contactor, both on the primary and the backup. Also in the picture, we're seeing an ECU, engine control unit, an ignition switch. This happens to be a key, even though some people ask me, what is this? Well, it's a key. It's a picture of a key. We have a couple of switches here, a couple of 15 amp breakers, one for fuel pump 1 and one for fuel pump 2. The second pump, again, is a backup pump. We have the wiring of the starter motor and the wiring of the alternator. So those are the basic components that are depicted. Some of them are laying on our table here as far as their physical appearance. We like the EarthX battery. This is actually now an outdated one. This is their ETX24C. The one that we're ordering now and have available on our shopping cart is a updated EarthX battery that not only has balanced charging across the cells, it also has a wire for a light giving warning if there is any problem with the battery. So these are kind of pricey, but they're very light, as you can see, and they put out a lot of power. In addition to that, there's an ignition switch. The ignition switch should never be used for anything other than starting the engine and keeping the alternator on and off, exciting the field on the alternator. You never want to go and wire your airplane and then put power to one of these terminals and then hook the computer on the other side, turn it on and go flying. Well, because it's not that reliable. You know, I don't care how fancy a one you get or you buy one from our shopping cart or whatever, but you don't want to use it for anything critical. We're going to talk about exactly how it gets wired in a second here. The alternator needs some protection as it is charging the system. What we like to do is just put a 60 amp ANL fuse with a fuse holder, also on our shopping cart, directly from the alternator through here and then power the battery. Very simple. You're going to need to get some of these breakers from Aircraft Spruce. You're going to need some 15 amps, a 10 amp, and that's for protecting your fuel pumps, mainly protecting, of course, the wiring in the airplane from fire, but also for shorts in case of a fuel pump burning up or something like that. So you're going to need a few of these. Aircraft Spruce has them, all different qualities. You might want to get the spade ones, or you might get the ones with the screws on them. But whatever you do, it needs to be good quality and a reliable component. Some other things shown here, just a typical switch. You can get different grades. Probably go with Aircraft Spruce again and get a high quality set of switches to turn your fuel pumps and such on and off. This is just an example of a bus bar. We like to have a couple of these in the airplane, one for, well, both of them designated to the engine. You definitely want to keep your engine wiring separate from your airframe wiring. And why is that? Well, because it's easy to troubleshoot. You never ever want to go and look at yours or anybody else's airplane and you have all kinds of wires stacked on all these terminals and you can't find out one wire going to another. The engine should have a positive bus like this and a negative bus like this, where you can organize your wires that are going to the various components. Wire loom. Anything that goes in the engine compartment, you want to buy the nylon type, or Kynar is even more expensive, but the nylon, they call it gray stripe. It has a little gray stripe on it. Split loom. It's a lot softer and much higher temperature rating on that than the stuff you buy down at the auto parts store that will go brittle either in the sun or from the engine heat very quickly. And you use that throughout anywhere to protect your wires from chafing. Some places you will need these lugs. We'll have a supply eventually on our shopping cart. You can also get them from various sources. You want the heavy duty ones. There are some thinner ones out there and there's some heavy duty. You definitely want the ones that have a little bit of meat to them. You don't need anything like that simple to fail on you. Get lots of nylon tie wrap or tie straps to bundle everything, make it organized. This is a diode. You would use it right here on the diagram. It's shown from the in post of the contactor to the small post on the side that is being grounded to close the contactor, and that's to keep a spike from occurring into the electrical system when the coil in the contactor is closing. You're going to need one of these for each contactor. We also have a small resistor here. It is a item that is used for the ECU or the computer of the engine if you are using the TAC output from the ECU output that says tachometer or TAC. Okay, it's going to continue on and go right to your TAC input on your instrument, depending on what instrument you're using, a Dynon or a Viking View or whatever. But you want to take the resistor and crimp on a terminal on it and put it to your 12-volt bus and then tie the other end to this wire. It's called a pull-up resistor, and it puts a voltage on this wire in order for this signal from the ECU to be recognized at the input of the instrument. Otherwise you won't have any TAC, any RPM. Now, another piece of physical component here is a cable. Everything that you use to wire these components together should be wired using Tefcell or aircraft grade cables and wires. Your whole computer system supplied by Viking and the wire loom that's on the engine is all put together of this high quality wire. Never do you want to get bare copper wire, very coarse wire. It should be tinned, it should be multi-strand, it should have the high temperature Tefcell coating, and it really is not that much more money to do one airplane with the proper wire than it is to get some automotive bare copper wire that'll corrode over the years. Another piece that we're showing here is the ECU, or the engine control unit, which is the brain box that runs the engine, the 130 engine. What you've got is a plastic box with two connectors on it. One connector basically has mostly wires to run the gasoline direct injection, and the other connector has multiple wires for sensors and so forth. The way that these are released, there is a plastic clip that can be just lifted up in the back at the same time as you pull out evenly on the connector. If you pull evenly, you put less strain and side loads on the pins, and that disconnects it. This is a weather-tight plug. Now, that being said, it doesn't mean that the computer itself is rated to be in the engine compartment. The computer should be inside the airplane, routing the cabling through the firewall using a nylon pass-through connector or bulkhead seal as shown on the shopping cart. The ECU itself, the back part is watertight, but the front is not. So you want to have it inside the airplane. If you mount it underneath where the glare shield or your window is and water runs in and comes all into the computer, obviously that's not very smart. Put it somewhere where it will always stay dry, or mount it like this so that the connectors are down. Then water can never get in, moisture can never get in. Do not open your computer. Computers are just like you buy an electronic or electrical component from an auto parts store, tested at Viking on the engine and found to be in working order, and then once it is shipped, it has no warranty, because it's an expensive item and it's a delicate item in the sense that reversing polarity to it would immediately destroy it. That being said, if it is wired correctly, it's very robust and will last a long, long time, and has all the latest in technology of solid-state components that can take vibration and so forth and so on. Rubber damping the computer as it's being mounted, though, is still a good idea, using some rubber feet. As you notice, there's only 2 feet here. What we have done is used 2 of the standoffs with a rubber insert, and then we've taken a foam pad in the front or in the back to stabilize the computer this way. The wires that come with the computer need to go somewhere, okay? Some of them are being shown on this diagram. Let's talk about them here, and then we'll compare them to the diagram afterwards. This DB9 connector is used for programming the ECU from a laptop computer. It can also be used to power the Viking View instrument and display engine parameters to the pilot. The other connector here says ECU power. It has 2 wires together, and both of them, the white with a red stripe and the solid white, go to power the ECU and the engine components themselves, such as injectors and so forth. So this is a very critical wire. Everything has a label on it with using shrink tubing and letters. This other white wire is labeled starter. So this goes out to the solenoid on the starter, It is actually not used for the computer system of the car. It's just provided in the wire loom to make it easy for you to wire the starter on the engine. This yellow with a black stripe says alternator field. We're going to explain how that is wired when we look at the wire diagram. We've got a gray with a red stripe, G-box temp or gearbox temperature. Again, it is not used in the computer system. It is just installed or inserted into the wire loom as put together here at Viking. And it has another end of it, also gray with red, that hangs over by the gearbox on the engine. And you would wire, you know, if you have a dynon or you have whatever instrument you have that's reading the engine temperatures and pressures and so forth, you would use this wire for your gearbox temperature. You'd put a sensor in the gearbox, wire that into that, and then this would go to your instrument. And then the final wire is the tachometer or tach wire. It is purple with a green stripe, and it would need the pull-up resistor that we talked about earlier for it to be able to read the tach and provide RPM output for the pilot. Now let's take a look at these wires in comparison to the wire diagram. ECU is shown right here. So we're really just showing the power going into the ECU. There's not much being shown on the diagram here of the wires coming out of the ECU bundle because most of them are not there to run the engine. The Viking builds engines, and we provide a computer that runs an engine. So basically what you're seeing is a power wire to the ECU, and that'll make the engine run. And that's this wire right here. Now, if you look at that closely, what you'll find is that the wire doesn't have a fuse. It doesn't go through any junction box. It just basically, even though it makes some turns here, it ends up right at the contactor, okay, and on this contactor. Now, if there's a bus bar here, as in your main power bus, let's say this power bus is right here, okay, and you've got power coming in from here to here and power coming in to here, and that's your main power bus, then your ECU can be wired to one of these screws. Now, that being said, you want as few connections as possible to run your computer. Why is that? Because guess what? If there's no power here, the engine won't run. So this is a very critical connection. You want to wire it directly so that when you turn power on from this battery or this battery, you have power here. You don't need a separate switch for that. You just need it to come on when you turn power on to the airplane. So that's how you wire the ECU power lead. Now we look at the things that are not on the diagram one more time in review, and this time not just more of a practical thing about what you have to do. Well, the alternator field, by the way, is in fact on the diagram. If you go over here, you can see that there's a wire called the sense wire. Okay, this represents the back of an alternator, the connectors. There's a connector here, a spade terminal. There's a connector here. There's also a spade terminal. We call this the top of the T when we talk to someone on the phone. The top of the T is the one you want to use to activate the alternator. Well, in order to activate the alternator, you're going to go to the ignition side of your ignition switch with a wire to here. Now, the other end of this is already hooked up to the alternator, so all you have to do is put this wire to the back of the ignition switch on the ignition terminal. Okay, and looking at this one, that's this bottom one. So that's going to go there. Now, let's look at some other ones. That's the practical way, as far as that's what you would physically be doing. The starter wire is going to go to the terminal on the starter that is there for energizing the solenoid. This other end of this wire is already plugged into the starter, so again, you don't have to do anything. You're going to plug this end that's provided to you to the S terminal of the ignition switch, which is the start position, which is that one in the middle. You turn the key to the spring-loaded position of the starter, and it energizes the S terminal, puts voltage through this wire, and energizes the starter solenoid. So that's the physical, practical thing that you're going to do with that wire. Gearbox temp we already covered. The other end is at the gearbox. And the tach we covered. You have to put a pull-up resistor on this guy in order to get voltage on it, so that this signal coming out of the ECU will show a tach pulse on your instrument. So that covers the ECU wiring. Now let's grab that ignition switch one more time, and let's take a look at the let's see if we can get this back on. There we go. Wiring of it. Let's see, right this. So we have ignition we covered. That's just going to be, it's not used to, in the traditional sense, for ignition as in a car. It is used, the ignition position is the position that you get to when you turn it on before you start the engine. Okay? It's also the position that it returns to after you let go of the key. That means your alternator is now on. So that's the wiring of that. Now let's talk about the reason for that. The reason for that is when you operate the Viking engine, you already got power to the ECU. Okay? If you turn this battery off, you still got power to your ECU. If you turn this battery off and this battery, you still have power to the ECU from the alternator. So the only way you're going to kill the engine is to turn the alternator off and the two batteries. So in order to turn this off, you have to cut the power to the sense input of the alternator, and that'll finally shut the engine down. When you do this as a test before shutdown, turn one battery off, turn the other battery off if you got them both running for some reason. The engine should still run, then turn the switch off and it'll kill the engine. Or you can do it the other way around. Turn the alternator off, make sure it runs on the battery, make sure it runs on the other battery, and then turn the batteries off. So that's a safety thing, and it just kind of makes the Viking engine have the features of a magneto-driven system where it is multiple ways that you can keep the engine running electrically. Now, there's also a battery terminal on this switch, and that is the top post on the ignition switch, and that gets powered through a 10 amp breaker from your main bus. Let's talk about the items on here one more time real quick. Put a main bus in here, power it up, put a 15 amp, then a switch and a fuel pump, and then ground the fuel pump. Don't ground the fuel pump to the chassis, and don't take the ground from both pumps and tee them together and put them on the chassis. Guess what? If that one screw comes out, you have no fuel pump. You need to think about how to do this, because you're now working on an aircraft and not a golf cart. So this is actually, it shows a ground symbol. It doesn't mean it's going to go directly to your chassis ground with a sheet metal screws. It's going to go back to your grounding bus in the airplane. And it's going to have its own terminal, and it's going to have its own wire for each pump, and that's how you're going to ground it properly. And same with the other one, another 15 amp breaker, a switch to turn the pump off and on. Use both pumps for takeoff and landing, like flying a Piper, and then use one for long distance cross country. Use one weekend when you go flying, use the other another weekend when you go flying, use this one again, and then just keep both of them, have fresh fuel circulating through the pumps to keep them happy for a long time without getting stagnated fuel into the pump. Another 10 amp breaker to power this. Ignition switch does two things: cranks the engine and engages the alternator. Output of the alternator, 8 gauge wire, 60 amp fuse, and this junction, by the way, right here, is actually the starter. You can run your cable directly from the output of the alternator through this fuse if you mount it to the engine somewhere, and then run this 8-gauge wire to the starter, and then on the same terminal run your starter wire back to the main batteries. It just provides for a nice clean installation. And that really covers the wire diagram. I'm going to throw in a couple of other things about the wire harness itself, since we have one here, and talk about the other end of the wire harness, which you never really have to do anything with because it's already mounted on the engine. But since we have it here, we might as well explain to you, since it's your engine and you want to obviously understand as much as you can about it, what's really going on. Some people know a lot about fuel injected or gasoline direct injected engines, and some people don't know as much about them. And some people have only had carburetors on their engines up through the years. So what we've got is a multitude of wires. All of them are Tefcell wire, all of them are color coded, and they all have a purpose. Now let's start kind of like in the back here. This wire happens to go to your crankshaft position sensor, which is located on the bottom of the engine next to the oil pan in the front, below the exhaust system. The crankshaft position sensor sends signals to the computer, allowing it to have full understanding of where the pistons are in the cylinders, and which piston is on its way top dead center, and also provides RPM output of the engine. We have another terminal here. This one is used for the variable valve lift. It goes to a solenoid. It's very simple, actually. Some of these things might seem complicated as far as the marketing of these engines. Companies will say, oh, we have variable valve lift, we got variable timing, we got this, we got that. Well, the basic operation of them are very simple. It's just a pulsed solenoid that allows a certain amount of oil flow to a mechanism to rotate the camshaft. If there's a failure of the system, it does nothing. It just kind of is stationary. But the benefit of it is huge. Having a system such as a variable cam is tremendous as far as being able to have excellent fuel economy at cruise and a large amount of additional power for takeoff. Now, working our way down the harness here, I'm going to pick a couple of more. We have one here. That's our air temperature. It just goes to the intake manifold and provides air temperature to the computer so that it knows how to calculate the amount of fuel that's going to go into the engine depending on the air temperature at the location of where the computer is located, as in the winter or the summer or high altitude or low altitude, hopefully not underwater. Then we got this guy, which is, the other one was variable valve lift. This is variable valve timing. Another solenoid that's used to move I take that back actually. This is a manifold pressure sensor. It's right next to the air temperature sensor. And it is used to measure the pressure that is in, or the vacuum that's in the manifold. This combined with the information about the temperature, the computer can then calculate the density, and from that find out exactly how much air and the density of the air that's entering the engine at that moment, and based on that be able to inject the right amount of fuel. This one goes down to the alternator, and so the other end of that would be the alternator sense wire, alternator field, alternator sense wire. That's already wired for you. All this, by the way, is wired for you. This harness is just laying on the table, but when you receive your engine, this is already on the engine and it's tied down and it's loomed and everything. But I just think it's important for you to also know what these components do. Here is the other one that does the variable valve lift. And one is timing and one is lift. This will, at 5,000 RPM, the lift of the intake cam is increased, and you will experience an additional power. You will also use a little bit more fuel. So as a practical term, that means that you would want to use 5,000 RPM and above when you want extra power for takeoff and climb and so forth. But if you're going on a long cross country, you might want to go down to like 4,900 RPM to get off that cam lobe, the high cam lobe, and the engine will run more efficiently as far as long duration and save fuel. This purple guy, it's got 3 wires coming to him, and he's important because he plugs into the fuel pressure sensor on the high pressure fuel rail on the gasoline direct injected engine. He measures the pressure at the high side, at the part of the injection system that's in the all-enclosed heavy-duty stainless steel rail that has over 2,000 pounds of pressure, which enables the engine to inject the fuel directly into the cylinder rather than to the intake manifold. Moving down the line, we got a couple of other important things. This one is used for the NOx sensor. The NOx sensor is there for a worst case scenario. Let's say you ended up with some bad gasoline, bad quality, and the ignition timing is obviously set for the proper gasoline. So if the fuel was not able to sustain and it would detonate in the cylinder, meaning it would burn too fast, the NOx sensor would pick up that frequency of the knock and would retard the timing accordingly to save the engine. This is the plug that goes on the starter, and that's what we referred to as the other white wire before. We're using a little piece of the Honda pigtail here just because it has a nice plug on it. And that's used to engage the starter using the ignition key, turning it to the S terminal to crank the starter over. These other 4 are the fuel injectors themselves. So they just go 1, 2, 3, 4 for the 4 cylinders of the Viking 130 engine. Coming up front, there's an important junction of grounding wires in order to have very little or low resistance of the grounds that are used in the electronics for the engine. You'll find this junction of ground wires secured to the engine with a screw and a lock washer, and it'll have a strain relieve here because of its importance so that it cannot fail. Next to that, we have a plug that's used for coolant temperature, and that's also used for fuel delivery by the ECU knowing what the coolant or what the temperature of the coolant is at that moment. It's also then used for starting and it introduces additional fuel for starting if it's a cold day outside. Here's that gray wire we talked about. It doesn't have a label on this side, but it does on the other side, and that's just for you to wire to a probe on your gearbox to be able to deliver that information to whatever engine information monitor that you have. This one is another important connector. It is used on the GDI, or the gasoline direct injection computer, as an input to the computer, but this end goes to the pump. There's a mechanical, all stainless steel, self-contained piston pump on the engine driven by the 4 lobes of the camshaft at the front end, and this connector plugs into that pump, and the computer regulates the amount of pressure that the pump is allowed to produce through a needle that relieves the excess pressure. So kind of like an internal bypass to the pump itself. In addition to that, we have a camshaft position sensor connector. The camshaft position sensor, the feature of it is to provide feedback to the computer Because the engine is a 4-cycle, 4-cylinder engine, the crankshaft position sensor would not be able to tell the ECU if it is on the firing stroke or the exhaust stroke. So the camshaft position sensor helps with that. And then there's 4 more connectors, and they are to fire the spark plugs. For those of you that are not familiar with these high-tech but yet kind of simple engine in the sense, is that you don't see any spark plug wires anywhere. Okay, this is all low voltage, low current stuff. These go right onto the ignition coils, and they fire the coils directly, which then fire the spark plugs that are buried in the engine. Appreciate you looking at the overview that we had here about the Viking engine and how to wire the right now the 130 GDI engine. And if you have any questions, we have a wonderful forum. We're always available to help you. You can call us anytime, well, during business hours at 386-566-2616. Viking is very big on customer service, and we really try to make sure that everyone have the components that they need. That's why we now offer all these components on our shopping cart, because some people do not want to have to run around town to buy these things. So you can get with our office and get some of the parts. You can call us if you have any questions. You can go to the forum if you have questions. There's builders on the forum that have already done what you're doing. And so lots and lots of help. Homebuilt Help has the complete video series on the Viking engine, on how to install it, including cowlings and electrical and wiring. They also have a huge library of other helpful videos that you would want to get to do proper wiring, what tools you need, what kind of cables, you know, all this stuff that if you don't know how to do this and you're not an A&P, Homebuilt Help will be able to get the right video so that you can learn this stuff. Thanks for watching. Okay, now you received your engine and it's on a pallet and you want to put it on the airplane. You obviously want your engine, and then get out your engine mount. You can paint that. Usually it comes to you in primer, so you can paint it with a urethane paint of your choice. Then install the mount on the airplane by using the appropriate bolts. Viking doesn't supply the bolts that go to the airframe because there's so many different airframes. But you obviously would want to measure the length of the bushing in the engine mount, and then add the thickness of the firewall, look at the drawings for the particular airplane you're working with, and then add these things together, and then enough for a washer inside and outside, and AN lock nut, and then order those bolts. You can use temporary hardware initially if you'd like, and then replace them as you go. Then put the mount up against the firewall, install the hardware, and torque it down. Now, if for some reason it doesn't line up 100% perfectly, a lot of times that's not avoidable, or it's unavoidable. So then you would pick the 3 that fits the best, and then kind of tug on the last one. Maybe put the mount on the ground and just give it a little bit of pressure in order to flex the mount until it will fit your firewall. The tubing is 4130 annealed tubing, so it's not a hard tubing, and you can bend it a little bit if need be. Most of the times it'll just fit right on the firewall. So that takes care of mounting the engine mount to the airframe itself. Now grab the engine with your engine hoist. Be sure that the airplane is stable, something underneath the tail, and that nothing can fall. Get the engine hoist, and then use the strong points of the engine with slings, and grab like for instance these standoffs up here with the gearbox area, right around here with the alternator. It's a very strong point, and find something on the other side, and then hoist and level the engine so that it is perpendicular or parallel to the airframe sitting behind it. And then gradually move it into position. Install your bolts in the engine mount. This hardware is available from Viking because it's always the same going from the engine mount to the engine. Now, put an AN washer on the bolt and put it through the engine mount from the back. Then add a large area washer to provide some cushioning for the rubber damper assembly. Now this can go either way. It can go this way. You see the two rubber pieces are slightly different. I would prefer maybe to put this in the back, because then when you slide the engine onto it, it has something to go up against. And then this goes like this and here. And then you have to get the engine close enough now, at least on one of the 4 points, that you now can put the engine across this, and then the other rubber part or half, which snaps on top of here and locks it in. Now, by the way, this has a steel sleeve in it, so you cannot compress this more than up to the sleeve being compressed. So you can torque it without like trying to balance how far you're compressing the rubber, because you're not really compressing the rubber, being that there is a steel sleeve inside. Then another large area washer, a small AN washer, and the AN lock nut. These, by the way, have enough heat resistance to be in an engine compartment, contrary to what some people might say. And then snug that down, and you can physically, rather than using a torque wrench on this, you can feel when it bottoms out. Obviously, you want to be careful that you're not bottoming out on the threads, but you should not be, being that these bolts are designed to go with this. But then when you feel the metal sleeve in here bottom out, when you tighten it with wrenches, just give it another 1/8 of an inch or 1/8 of a turn, and then that's as tight as you want these to be. And then do this to the other 3 locations around the engine, and that completes the installation. Now, at that point, you might want to verify some things. Your airplane installation manual might say things like the engine should be level with some reference point on the airplane, or it should be 1 degree down. Well, in most cases, being that it's hanging from the top mount and is pushing against the bottom ones, it automatically will be down just a little bit. Now, if necessary to shim the engine up or down, you just do that simply by adding washers behind the bottom mount on the lower 2 engine mounts. Now, Viking GDI gasoline direct injected engine has a universal cooling system, in the sense that the pieces that are needed for a variety of aircraft, including gyrocopters, fixed wing, and so forth and so on, are very similar, and they can all be had at the Viking Aircraft Engines shopping cart. What you're looking at here are some of the, or basically all of the components needed during an installation in all airframes. You'd need a radiator. You would need, if you live up north, some kind of a heating system, which is also available from Viking. Some hoses for the heater, the switches and the clamps and the instructions for the heater. You would need connectors to go on your radiator in order to have them come out at the right angle, either a 45 or straight for a hose, or at a 90 degree, depending on where your radiator is located and where you would like to go with the hoses. You're going to need some connector pieces after you're fitting the system up with either a 45 or 90s, or maybe 135s, which are at least one that's used on the Viking engine. And connector pieces to connect this together. Clamps of various sizes, mostly because the clamps that are sold at the Viking store, there's 2 sizes. One is used when you're connecting the system together with other components. The other one is used when the hose goes onto the engine or when the hose goes onto the radiator. Because it's a silicone hose, it's very flexible and it can actually fit on various diameters of fittings or tubes. When it goes on to here, you're going to need a little bit of O-ring grease, and it'll go on kind of snug, and you're going to need a big clamp. When it goes on to this aluminum tube, you will use a little bit of O-ring grease as well, and then use a smaller clamp. The last components that are shown here is your neoprene or neoprene hose with a very small inside diameter, very tough hose, meaning that like it is so stretchable it would actually even go on to here. And it has a lot of wall thickness for chafing protection when it is running around on the engine and scraping up against items. So with these few items, you can build a cooling system for any aircraft using the Viking engine. And because there's no pressure in the cooling system, you never have to worry about any sizable leaks. Now, let's go and look at the system on a Zenith 750. This happens to be a cruiser. Of course, the 750 and the 650 and the cruiser are all the same. So this would be an installation that would be applicable to those. It would also be applicable to any airplane using these exact components. The only difference would be maybe the slight location difference of the radiator as far as fore and aft, if there's a nose wheel, not a nose wheel, so forth and so on. Now, there are basically 5 openings or 6 openings to the Viking engine that have to have something done to them as far as the cooling system is concerned. There's a top plug here which is used to fill the system after everything is done. Then there's a little nipple here. This is where all the air that is escaping from the bottom of the cooling system and the radiator escapes out in order to purge the system. This hose goes to the coolant tank that's mounted on the firewall, and it is actually vented through the cap. It doesn't look like it would be, but you see this little hole in the rubber up here? Okay, that's how it's vented without spilling coolant, and then it vents through the threads and out. So that is a vented coolant reservoir that fits this hose and gets mounted to the firewall of the airplane. You want to keep it to the first line after you have it all purged and the engine is cool. At operating temperature, you'll see it go to the middle line, maybe a little bit above the middle line. And mount it as high on the firewall as possible. If you have to mount it lower, it is not critical. The one thing that is critical is that this has always got fluid above it. You never want this to be empty, because then when the engine cools, it's going to be drawing air into the engine rather than coolant. So that covers these 2 openings, the fill and the bleed of the system. Let's cover the other 2 smaller openings. One is a port on this side, which is for your heater. Okay? There's a plug in it that you would remove, and you would screw a brass barb in here, and you would hook up your heater hose and run that inside or up to the firewall, where you would install your heater inside, blowing down onto your feet. You would drill holes in the firewall and you would push this through so that the fittings for the hose are outside in the engine compartment, but the physical heater is inside. And you would use a switch where you can control one fan or the other fan, or both fans, or actually one fan or 2 fans, to regulate the amount of heat that's blowing down onto your feet. In fact, the fans are pulling, so you would mount it like this and the air would pull down and go down onto your feet. The return for the heater would then go to the other opening we're going to show you on the engine, which is located here underneath the intake manifold. Right here, when the engine is shipped, it has a short piece of hose and it has a plug in the hose. Okay? So that's how you would leave it if you are not using a heater. Now if you're using a heater, this would be the return side from the heater. So you would then remove these clamps and you would put a 90-degree heater fitting in there, and then you would run from there to your heater, to the other side of the heater. So that covers the four small openings. One of the larger ones is also right here. It's the thermostat housing. That's actually the return from the radiator. Let's get to that a little bit later. Let's talk about this one up here, which is where the hot coolant, after it has cooled the engine, exits and then is brought to the radiator in order for the coolant to be cooled by the radiator and then recirculated back through the engine. Now, while we're up in this area, let's also point out that both the computer and your instrumentation would like to know how hot this coolant is. Now what you're doing there is the computer is reading it through this probe that's already wired when you receive the engine, and your instrumentation is going to be reading it in a probe that's behind here. It's a little bit tough to get to, but you can get it because it has a NPT plug in it, and you can get it from the other side here with a little ball at the end of the Allen. Take that out and then put your probe down in there and tighten it up. The reason that it's located there in kind of a little bit of an awkward spot is that that is the perfect location to get the maximum temperature of the engine before it exits the engine and goes down this hose and then to the radiator. Now, looking at this, we have here a 90-degree elbow. So you would basically watch this video and make yourself a shopping list if you had an airplane similar to this. You would need this 90-degree elbow and these two clamps. Then you would need a section of tubing of a certain length. Then you would need the 45-degree elbow down here. And another section, 1-foot section, these two, of tubing, and a couple of more clamps, and another 90, and a couple of clamps, and you'd need a straight-in fitting for the radiator, which is also then available. So it's a modular system where you would put it together the way you want it to be, or you can copy exactly what we have here and do it that way. As it goes through the radiator, which is belly mounted on this airplane, and has worked out very, very nicely because our cowling goes down like this, and the radiator is almost not even visible from the side of the airplane. It has a very low profile drag, and in fact when you view the airplane from the front, this is very, very minimal as far as the extra area, because the cowling has to come down in this area anyhow, be it an air-cooled or a liquid-cooled engine. And then all this air goes in here, and this is blocked on the sides, and it's also blocked on the back. And we'll do a little bit of explaining of how this radiator was mounted on this Zenith airplane in a little bit. Now, the coolant then circulates through the radiator and comes back out on the other side, and we're going to get a little bit of a view of how we get from there back to the thermostat on this side. Well, let's just backtrack. We go on this end with a 145-degree silicone hose and two clamps. Okay, then we have a short piece of straight, and then we have a 90 to get around the engine mount, and then we have a piece that's specifically for the Zenith that has a little weld in it that's also on the shopping cart, and it has a 45-degree weld on this side. And then it goes into a 90 into the radiator, and then another hose barb fitting that snaps onto the radiator. These radiators have an O-ring in these fittings, and they have little clamps, little spring clamps, that when you snap it on here, it locks in place with the O-ring inside here, and you can convert this outlet or inlet to a straight or a 45 or a 90 like we explained earlier. And then you use the big spring clamps here and on the other side, and then the smaller ones generally other places. Here's a particular, you can order this welded up assembly here, this pipe for the Zenith, or you can now, using the modular method, and get a little straight, and you can go with a 45-degree hose here. So there's various ways you can do it. If you want to copy this exact one, then you can get the Zenith hose right here, or the aluminum pipe. Now, that is actually all there is to the cooling system. Other than that, let's take a look at the thermostat and explain a little bit about that. This is the original Honda thermostat. It is, you should watch the temperature as you taxi out, right around 168, 170 degrees. You can watch the temperature start dropping again for a little while, and that's how you pay attention to that the thermostat is now opening and there's flow through the radiator at that point. There's also a bypass hose right here, which is of no real consequence. You really won't even really know that it's there because it's already plumbed and finished for you. But this hose goes underneath the manifold and is also entering at the bottom of the thermostat underneath your heater return. And what that does is provide a constant amount of bypass hot coolant. As you can see, it's also coming from the hot side of the engine, and that's what actually physically opens the thermostat eventually. And it provides a little bit of bypass, so contrary to most airplanes where you get in and you're cold for the first 5-10 minutes, there's instant heat here provided for the heater for two reasons. One, because of the bypass, and then also we're going to look on the other side of the engine again at the exhaust side, which is the other reason why you have instant heat. The exhaust manifold is built into the engine. It's a clever design, and because the exhaust is going through this manifold and it's made out of aluminum, it has to have a lot of coolant jackets around it or it would physically melt. The aluminum couldn't take that kind of a temperature. So as soon as you start the engine, within a few seconds you have the temperature needed in the coolant to provide comfortable cabin heat for the occupants. Now let's take a quick look at mounting the radiator in the Zenith. If we start with the quick view inside the airplane, we can get the location of where the radiator would be mounted. As you can see on the floorboards here, we have some dome nuts. Okay, and if we count some rivets here, well, basically we have two rivet lines here in the floor that hold a hat section on the belly of the airplane. And it happens to be that the aft line is exactly where the dome nut is, and that holds this corner of the radiator through a rubber hanger underneath, which also of course is available through Viking. Now when we look right underneath the airplane at that location, we can see that, you know, this being a prototype airplane, we have tried this and we have tried that, and now everything is working. But of course you have a little bit of goop and stuff here to seal up the holes, but here you can basically see what's going on as far as the attachment of the radiator. There's a two-sided, it has a thread on this rubber part that screws into the plastic here on the radiator, and then it goes through the floorboard. In fact, this is a 1-inch spacer rubber hanger, and then we also have two 1/8-inch washers, rubber washers, so it gives you a total of 1 1/4. And then basically and simply, this is tapped with a 6mm, and then this is screwed into here, and the same on the other side. Pop it through the floor, put a acorn nut on top, and that secures this side of the radiator. And just as simple as that. And you can also see here's this hat section we talked about, and we're able to put the hole in the hat section in order to get a little bit of extra strength, or at least be close to it. Now you also see here while we're here that a little bit of sheet metal was cut, and it was put into the back here, riveted, then in the forward section of the hat section here, and then some side pieces were put in with what we call the zenith angle. Lots of these zenith angles are available in a zenith kit. And then just some straight aluminum down onto the side of the radiator, just kind of like laying up against it. And that's as simple as it is. Just close the back, put a side to it with an angle. In the front, you might want to either make it adjustable, like we did, or you can make it fixed. You're going to need about 3 inches of opening here in the front to allow for a proper amount of air to enter the cowling area. And you want to try to keep this, not the cowl area, but the radiator area. You want to try to keep this unobstructed. Well, we have the nose wheel here, but we don't have a lot of hoses and things like that going through or in front of that area to try to keep it clean. Now, what we did here, because we wanted to make it adjustable, we put 6mm threaded rod that we screwed into the radiator here. We tapped that with a 6mm tap. Very, very careful so we don't go too deep, because it is a plastic radiator. And then we screwed that in with a little bit of blue Loctite on both sides. We built this little shelf here. Now this is something that's a little bit different. You might not need this shelf. This is something that we built when we were prototyping different things on this airplane. But you would need an angle bracket off the firewall, kind of in line with where these covers are for the rods going through for the steering, at the outer part of that. Right at the outer part of those, in line with that edge, it's pretty much where you would put an angle down the firewall and out to create a hanger or a bracket, which you would then drill for the 6mm, and then you would put a couple of rubber 1/8" rubber washers, and then you put a nut, and then the radiator would be hanging from there in order to and then of course the side panels and everything would also make the thing, keep that from going up and down and so forth. Once you have your height set, you can even put spacers in here, and that locks it in place. But of course you kind of want to let the rubber do a little bit of cushioning so that it's not totally rigid. And that explains the installation of the cooling system on a Zenith airplane, which would be very similar to your RANs and your Vans and all these other types of aircraft that are out there. As you can see, it's very modular and it's very simple. And there is no pressure, so you won't have any problems with leaks. This is the layout of the gearbox that is used to power the propeller on a Viking 130 engine. While we have it here, why don't we just take a quick peek inside so you can see what your gearbox looks like. It's a very robust gearbox built for long life. It uses precision ground and hardened gears. It has plenty of support for the propeller with dual bearings up front and a bearing in the back, a bearing on each side of the either gear, and then roller bearings on both sides of the input gear. It is sealed with the rubber insert here when it is put together. If you ever have to do any service to it, if it ever has to be taken apart, there are tapped holes provided at 4 different locations where you'd use 6mm screws and screw those in, and that will push the gearbox away from the engine. The propeller hub should never be removed, and if it ever was, this nut would have to be retightened, and it has a lot of torque on it. There's a seal back there. We never have any leaks of them, but if you ever did, then yeah, then you'd have to take this apart. The way to take it apart would be to get a big 2x6, drill some holes for these, put that over here, let it go down and hit the ground, then get a huge bar for this in order to take that off, and then pull the seal, put a new seal on, and then reverse the procedure, put it back on. So that's the only maintenance I can ever think of that you would ever have to do to the gearbox. We've never had to do anything, so chances are you get years and years of service out of this heavy-duty gearbox without touching it. Now, important parts are keeping oil in it in the proper amount. What we have on the bottom, it's a magnetic plug. You can pull it on occasion and see if there's any files on it. Probably the first time you run it, you might get one or two hairs of something, but then after that it should be clean. This hole is tapped on this radius. This will change in the future, but now the units that have gone out are like this, which means the thread is kind of on the crest, or on the top of this hill, and it's very easy because of that to cross thread it. So just be very, very careful when you start it, and go in by hand first. Put a little pipe dope on it, and now in the future this will have a flat spot on it. Well, this will not be the case, but just letting those that have this particular version of the gearbox know that point. Now, here's a fitting that's provided and screwed into your gearbox. This vents the gearbox from a location internal to the input gear. The input gear is hollow, and the nice thing of venting it right there is that there's no centrifugal, there's no motion by the gears to force oil out of the gearbox. So it's an ideal location for the venting of it. Now, your engine will be supplied with this high temperature clear tubing, and it will be installed in this fitting. If you ever have to remove it, you just pull this green part in, and then the thing will come out. But if you don't push on that, then it is in rigid. This, of course, will be nice and tight. Run this hose. You'll get a long piece supplied with your engine up to the firewall, and get another one of these vent bottles that we showed for the cooling system, mount it to the firewall, and get a piece of 1/4-inch fuel hose, and then connect that to the clear tube. You can get a couple of spring clamps if you'd like, to make sure that that's nice and secure connection. You will not see oil in this all the time. You might see it after running the engine for a little bit. That is because, or after you shut it down with a warm engine, where the oil is warm. That's because, like we explained, the inside of this gear actually has very little oil when the engine is operating, and centrifugal force is pushing it out to the side. Now put 8 ounces of Mobil 1 synthetic gear lubricant 75W90 in the gearbox. The fill is either here or here, depending on. You can use either one of these for a probe to measure the temperature of the gearbox, and then use the other one to fill it. Now, putting the 8 ounces in is pretty easy. It's also it's easier if you remove both plugs during filling. But you can also just fill it, but it will take a little bit longer to get the gear oil into the gearbox if you're just relying on this as the vent during the filling process. We're looking at the exhaust system on the Viking 130 engine. The engine is supplied with a muffler and a exhaust manifold and a slip joint. The engine itself has 4 studs, exhaust studs, installed ahead of time. The next thing that needs to be added is the gasket from Viking. Add it in the correct direction. Basically, if it's this way or that way, doesn't matter, but as you can see, the holes are wider here than here. So install it on the engine. Then install the small exhaust manifold, which is basically just this plate with this tube on it that goes to about here. Put a lock washer on and a nut, and tighten and torque equally to 250 inch-pounds. Then grab the muffler assembly and hold the whole thing, kind of tilt it until this slides onto the pipe. It might not slide on this way if the pipes are not perfectly round to each other, so you might have to lift it and find out where they engage, and then slide one into the other, and then shift it back. You can put a little anti-seize in here if you'd like. Then push it back until it aligns the two holes in the back tab of the muffler with the stainless steel triangular bracket that's bolted to the aft end of the engine. And during pre-flight, as you're operating your engine, carefully check in this area for cracks. Check cracks in all the welds and in the tailpipe. And that's all there is to do with the muffler.
This is the basic fuel system for the Viking 130 engine. This is also a prototype set, and so all parts will not be identical for the production version, but the principle will be the same. At this end is where fuel will enter the system from the airplane fuel tanks, or fuel tank in the case of, let's say, an RV-12 that has a single tank. You as the builder are then responsible for providing to this location a steady and reliable supply of fuel. Fuel meaning for the Viking 130 engine, auto fuel of a mid-grade or a high-grade quality. 87 is not recommended. It can be used at your own risk if it's very fresh fuel. The engine is protected as far as detonation, but personally at Viking we never use it. We use mid-grade or high-grade. You can also use 100 low-lead aviation fuel in the engine. This being a reliable source of fuel means to you that you need vented fuel system, gravity feed, test to make sure that when the tail is pushed to the ground, or depending on the configuration of the airplane, that there's a gravity feed of a minimum of 15 to 20 gallons an hour at that location at all times, no matter how little or much fuel is in the airplane. The fuel pump then assembly can then be mounted anywhere in the airplane that meets that requirement. As the fuel enters the system, it will flow over here, and as you can tell there's two bodies here and two filters, meaning two fuel pumps and two filters or pre-filters. These are low pressure filters. Fuel will flow through this filter and be readily available to the inlet side of this fuel pump. Fuel can also flow through the secondary filter and be available to the inlet of the secondary fuel pump. Now, I refer to them as primary and secondary. The truth is they are actually identical. Either pump can be used for flight. We recommend using one pump for one flight, another pump for the flying back home and so forth, in order to always keep fresh fuel flowing through the entire system. If you were to allow one pump to be a backup pump and never use it, chances are when you do want to use it and you've been running auto fuel in here, the fuel will be all gummed up and the pump will not work when you need it. The outlet side of the fuel pumps have built-in check valves internal to the pump. So fuel that is being pressurized through this pump body will not be able to flow backwards through the other pump. And the same, if you're using this pump, it will not flow backwards through the opposite pump. Now, some return flow is present. In this area, this brass fitting right here is a reducer. Okay, it is a reducer that brings a very small amount of fuel back to the inlet side of the pumps. Normally this is done in a fuel-injected engine with a pressure regulator. Because the GDI engine, gasoline direct injected engine, is not very critical as far as the exact amount of fuel that enters the mechanical pump on the cylinder head of the engine, we're not using the fuel regulator with a return back to the fuel tank. We're simply bleeding off some fuel pressure back to the inlet side of the pump to allow the pumps to run faster with less load and thereby also cooler. At the exit of the system towards the input of the engine-driven pump, we have a transducer that's used to measure the fuel pressure for the cockpit, for the instrumentation in the cockpit. We also have a high-pressure filter that is a last resort filter before the hose going to the fuel pump on the engine. Some might say that this transducer belongs on the other side of the filter in order to measure if this filter ever becomes contaminated. For us, it was convenient to put it right here because we were able to put it in a threaded fitting, and we're not so concerned about this filter clogging because we have primary filters, and the only possible contamination that can get into this filter would be a deterioration of the pumps themselves, which is extremely unlikely, and even if they did, there would be very little contamination in the filter prior to changing it on the annual inspection. This area of the assembly will be replaced on a production version with a machined fitting that will eliminate all these brass fittings. And it will also have a hole available where you can ground this assembly to the airframe. And you want to ground it because if you don't ground it, you can see this is all rubber mounted. The transducer here, when you put the wire on to your gauge or to your instrumentation, will not be able to read any fuel pressure unless the body is grounded. We have used this type of clamp that we also use in our cooling system, and we squeeze the clamp and stick a wire underneath it and then run it to a ground. But we will provide a grounding lug or hole in the block for that purpose. Now, it might seem convenient to then run a ground directly to the pump ground, but you don't want to do that because the pump has a certain amount of draw and it will skew the reading from the transducer. So you want to run a separate ground all the way back to your grounding bus of the airplane. As far as wiring the pumps, we have talked about that before. Be careful in the sense that a couple of little things. These Oetiker clamps that are used, make sure they don't point towards your terminals because you could short out the pump. Make sure that you don't ground this to the other pump and then to the chassis or to your grounding bus because you're introducing a single point of failure, whereas if you were to ground this pump directly to your aircraft grounding bus and this pump also directly to your aircraft grounding bus, but with separate wires, you would have a truly redundant system. The positive side of the pumps will then go to your 15 amp breakers and your fuel pump switch and then to your positive bus of the airplane. Now, in general, when you receive this assembly from Viking, you can buy it all put together on the shopping cart. You will install it at a low spot in the airplane. It is now low pressure in this area up to here, and then all of this is a high pressure system here, so you cannot use like these little spring clamps at this side because it will just come apart. Then everything from here to the engine is a high pressure system. Your engine will also come equipped with a plastic fitting that snaps onto the fuel pump, the mechanical fuel pump, and it has a barbed fitting, which means this hose would go unobstructed or uninterrupted, as in it would be protected from chafing throughout the airplane, and it will go all the way up in through the engine compartment and up to the inlet of the high pressure pump, and then attached to the specialized fitting that snaps onto the high pressure pump using the Oetiker 14.5 millimeter clamp or a specifically designed fuel injection hose clamp that is available.
Okay, here are the fuel pumps installed in the back of a Zenith Cruiser, which would be the same as any Zenith 750. Basically, the fuel pumps should be mounted low in the airplane in an area where you can, like for instance here, this airplane has a header tank. You can see it in this corner here. But if it didn't have a header tank, or if it does have a header tank, doesn't really make any difference. You want the fuel to come from the wing tanks and then run down to the inlet side of these two fuel filters. And the same from the other side of the airplane, come down and feed these two fuel filters. The way the fuel assembly is shipped, it has a T here where there's only one inlet, which then of course would be from the two wing tanks into one. And then that would feed the fuel pump assembly, as we discussed earlier, how that all works. Needs to be mounted with some clamps and need to be wired up per the wire diagram. The high pressure filter is here. The low pressure is on the inside or the inlet side. After the high pressure, there's just a continued hose that goes, in this particular airplane, underneath the airplane all the way forward to the engine compartment. But we'd like to see an uninterrupted hose or connection between there and the engine, so there's no brakes or fuel connections at all inside the airplane cabin. This shows also the fuel transducer that measures the pressure of the system. It has a ground that goes to the chassis ground here, or airframe ground. Better yet would be to run a separate ground wire all the way to your grounding bus. Now, as far as water trap, if you want a gascolator, what we have is a drain in the header tank that we drain and sump on a regular basis for water. I would not put a gascolator on the firewall or anything in front of the high pressure filter. Once it goes through and becomes high pressure, there should be a minimum of connections in the system. There certainly should not be any kind of a gascolator on the firewall picking up all the heat from the engine compartment or anywhere in the high pressure side. A gascolator would only have a purpose on the low pressure side if you insist on using one, or just have a drain at the low point and a drain in each wing.
This is what you're going to do to install the fuel hose to the engine from the output of the high pressure fuel filter. Your engine will be supplied with this fitting. By squeezing these in, you can pull this out. This has a O-ring inside, so it doesn't feel like it's a very secure setup, but in fact it can take a lot of pressure, and this is all rounded off, so there's no chance of damaging anything. And it's a very simple, of course you got to line up these holes with the grabby things in the plastic here, and that snaps right in place. Now, when the engine is shipped, it comes with this fitting. What you need to buy is some 5/16 fuel injection hose and the Oetiker clamps. You put a little bit of lubrication in here, the O-ring grease, and then push that onto the hose and all the way up, and then use the Oetiker pliers to squeeze the clamp all the way. It makes a nice secure fit, and then from here the hose will run underneath the intake manifold and towards the back of the engine and through the firewall. You obviously have other options. You can run it down through this side and along the bottom of the engine. That's totally up to you where you want to run it. I would recommend that you tie it to the engine in various places and make sure that nothing sharp is chafing into your high pressure fuel line, or relatively high pressure I should say. Now, in order to start the engine, the hose is already on. You got your fuel pumps pressurizing the system. This GDI, or gasoline direct injection pump, has to have fuel to it in order to build rail pressure, it's called, from here to the fuel injectors. It will not be able to build any pressure if there's air in this line. So what you want to do is you want to squeeze this and take this off, and get a bucket and have a helper turn your fuel pump on and let it run for a little while, make sure there's no air bubbles anymore, into a bucket, and then just as somebody turns the fuel pump off, you want to keep in mind that these have to be aligned with this. You quickly put it on like this, and then that keeps fuel and not air into the system. Now, if the engine doesn't start right away, you can redo this procedure. Now I would leave the pumps off, and I would put a rag over this. You can hold this up and squeeze this, and you can actually, like, very carefully move this down just a little bit to undo the clips, because the O-ring is still sealing, and then put a rag on it and pull it off the rest of the way, and then redo the procedure, put the pump on and put it on again until the engine will build rail pressure from here to the injectors and inject the fuel and start the engine. Okay, you've got the engine installed and you're ready to put fluids in it. We talked about the gearbox, that you put the oil in there, and you have a sight glass up front through the tube that you can inspect on occasion. The other fluids that you will need would be oil. The engine use is 020 car oil, and you would put in what we use is the Mobile 1 synthetic. So you run 0W20 Mobile 1 synthetic oil in the engine, along with a filter change. And you could do that at the first flight. Just use some inexpensive 020 oil, and then change to synthetic oil after the first flight, and a new filter. From there on, just use the synthetic oil. The level of the oil should be between the top and bottom marks on the dipstick, with the airplane, or the engine actually, level, depending on what type of plane you have. That takes care of the oil. You have, as far as the oiling system, it's putting the oil in, checking the level. The filter is on the other side, but before we go there, this is a breather for the venting of the crankcase pressure that needs a hose either running overboard like this, or in some engines we provide a nipple that is pointing this way. You could put a hose on that and run it down and shoot it right onto the exhaust system, so that if any oil were to come out, it would burn up as it hits the exhaust. We'll go to the other side. There's also a crankcase vent on this side. Luckily, the 130 engine has almost zero blow-by or oil coming out of the engine. But there's a hose in the back here, right here, that also runs down and can be found down here underneath the engine. Comes down this way, and we just have it, we have a 90-degree here, and we go back and through this hole and out, because we don't want to have any oil in the cowling. So you've got this side and you got the other side. Here's the oil filter. So that's a convenient place to have an oil filter. You would just spin that off with a bucket underneath and replace it with a new one. In fact, you can replace the oil filter as often as you want, even more often than the oil. Now, as far as coolant, you would fill it here. What we have done is we make our own. We buy a transmission funnel, which is kind of like a big funnel, and we put a hose at the bottom and we clamp it on here. That way we can put the coolant in it, and it will just sit there and dribble through and allow the air to escape until the engine is filled up. Now, the type of coolant we use is the Evans, and it's high performance waterless engine coolant. This type of coolant does not need or should not have any water in it. In fact, there should be absolutely no water in the engine. It works by having an elevated boiling point, and because it doesn't boil at like water at 212 Fahrenheit or 100 Celsius, you're able to run no pressure in the system. The reason that we have pressure in our cars is to be able to raise the boiling point above 212 degrees Fahrenheit because there's water in it. Since there's no water, it will not boil, and we can put it in straight, and we don't have to have a pressure cap, a radiator cap. In fact, this hose runs to the overflow coolant tank that's mounted on the firewall back here. And it's just a very simple tank with a vented cap. In fact, you want to make sure that it stays vented. And it's vented to the atmosphere. There's no pressure in that system. Now, you want to fill it until when it's warm, it's at the first or between the first and second line, and when it's warm, it'll be at the second line or maybe between the second and the third. Initially, it's very important to continue filling at the forward location here, at the fill plug of the coolant, and you might even operate the engine at idle with the funnel and some coolant in there, and bring it up to operating temperature and shut it down, and do that a few times, making sure there's always coolant available to be drawn into the engine in order to get all the air bubbles out of the engine passages and the radiator itself. Okay, here's the routing of the throttle cable. In fact, the throttle cable comes out of the firewall at the same location as the rest of your wires, and we have it protected with split loom because the metal housing of a throttle cable is very kind of hard, and it will chafe into various things on the engine. Now it runs here and it's tied to the manifold back here. Then it goes, and there's a plastic hole here. You can put tie wraps there, and then there's a clamp here. Bring her around in a nice gentle curve and tie it again to the manifold here. It's provided a location for that. And then put the cable through the provided bracketry that comes with the engine. Make sure that you use this clip that's also provided with the engine. Do not get a throttle cable like from a local whatever store, because you do want the aircraft spruce part number that has indent or a groove that fits the indent in this clip. And when you tighten it down, make sure that the indent aligns with the groove so that it cannot slip out, and then you'll have no throttle. From there, it goes forward and is attached to the ball and socket that's provided with the engine that uses the 1032 thread. So basically, from spruce, you want a universal throttle with a 1032 end, and usually a throttle has a black knob, and I forget the part number, it's like 800 or 810 or something for this cable. Now there's an idle adjustment on this as well. We're going to show that on a manifold that has that implemented over here. And you can see that the manifold itself has a bracket on it that's part of it with an adjustment screw. Now obviously the way that that would work is you screw this in and out and you lock it with this little lock nut or the jam nut until the throttle stops against it, and that's your idle. The full power position is done internally by the butterfly valve hitting a piece of plastic inside the manifold, and the idle is done here. After the propeller is on and the engine is running smooth, you want to set the idle at between 14 and 1600 RPM engine RPM in the cockpit. As far as doing the wiring for the alternator, it's pretty simple. The harness already comes with a plug that goes here to the top of the T. Just make sure that you squeeze this terminal a little bit with pliers, so when you push it on, it's nice and secure. And then that goes into the airplane, and it goes to the ignition terminal on the ignition switch like we talked about. The output stud of the alternator is what charges your batteries. The fastest way to get that to the battery system of the airplane is to run a 10 gauge wire from here to, get a fuse block and a 60 amp fuse off the shopping cart and mount it somewhere on the engine. Like this has a little hole drilled in the bracket here, and it's been mounted. And then come off the alternator, strain relieve the cable so it cannot break by vibrating, tie it to the alternator, and then bring it to the input side of the fuse, and then from the output side of the fuse bring it to the starter lug terminal, which is also where the main starter cable will come in from the battery. It's a little bit tight to get to on this engine, but it's back here. Uses a 12 millimeter nut if it's a original nut. If it's an aftermarket nut, it uses a 13 millimeter. So usually you can get in here with a short socket and a small ratchet and take that nut off. Okay, the starter looks like this for the engine. This is the terminal that's used for energizing the solenoid internal to the starter. That wire is already put into the harness, and the other end of it is in the airplane by your computer wires, and it then goes to the starter terminal of the ignition switch. This large lug is where power is provided from the battery to the starter terminal, and also where you'd put your alternator cable coming from the alternator fuse mounted on the engine. So from here you can use a 12 millimeter if the nut looks like this with a built-in washer. That's the original equipment nut. If this is missing and you use a aftermarket or commercially available 12 millimeter by 1.5 thread, then it would be a 13 millimeter socket that will go on here. So you would combine two wires, the one for the alternator on one lug terminal, and then another one with a 6 gauge cable shown on the wire diagram that then will go from here into the airplane, and we'll go into the airplane and show where it ends up. You can see the starter bolt or nut, I should say, down in there. And that's where the alternator wire would end up. And the reason that it goes to the starter is not because we're trying to power the starter, it's because it also ties in with the bigger cable, the number 6 cable that goes from there and then routes underneath the manifold and then in with the rest of the wiring into the cockpit and to your batteries. You can see the cables here, these two. One is the power cable for the starter going to the battery, and we'll look inside the airplane in a second to see where they end up. Now, as far as the grounding side, there's obviously multiple places on this engine where you could bolt cables for grounds. We ended up using some locations here, this one and also one up there, and we have 2 cables. One is redundant to the other, one goes to each battery. This is also an engine mounting location, so you can use that, or if your engine doesn't have a stud here like this one, you might not want to take that cable out, and you can use other places where you can bolt a lug that will work on a number 6 cable for your battery ground. Like, for instance, looking around this engine, you have multiple places here. On the other side of the engine, there's more holes like these. This one, of course, is too close to the exhaust. But this type of a hole would be a 8 millimeter by 1.25 millimeter thread. There's one down here on the oil pan, obviously a nice location if paint was removed. That's a 10 millimeter by 1.25 thread. So if you look around on the engine, there's multiple locations that are already tapped holes where you can put your ground wires. And then if you look at our previous videos, which have a lot of detailed information about how to do wiring, you'll see that all these kinds of things have to be then strain relieved. You cannot run a cable from here and then have it dangle and go into the airplane, because eventually it will break right at the terminal. You then have to also use another place to tie it to so that there's no vibration introduced to the terminals. Obviously, the grounds and the power cables for this engine are very important. Now we're inside the airplane that has a Viking 130 engine up front. This airplane has a fold-down panel that we made just to kind of make it easier to get behind it. And it has the switches over here for the engine. Basically, it has a battery 1 and a battery 2, and it's got fuel pump 1 and fuel pump 2, and then that's it. When you turn the battery on, the computer comes on and the engine is ready to start. So basically, you're going to need one battery and one fuel pump. If you want to put both batteries on for start, you can. You just make sure that one is always available as a backup source. So the whole starting procedure would then be get some battery power, which also would then power up your computer since it's wired directly to the contactor according to the wire diagram. Put on one or the other pump. You can probably also put 2 pumps on. We'll talk about that in a little while. That adds a little bit of extra pressure for starting. And then turn the key and hold it until for like 2 or 3 seconds if the engine doesn't start. Of course, the throttle has to be all the way to idle. This is not a carbureted engine, so there's no jockeying around with the throttle, desired or needed, and it should always just be at idle. And then crank the engine until it starts. If it doesn't start within the first 2 or 3 seconds, turn it off and do it again, and then it'll start right up. Behind the panel, we are seeing just the basic wiring that you're going to end up doing, which is this switch and this switch are providing grounds to the contactors, contactor 1 and 2. So basically this wire and this wire, they get grounded. If you took a test lead from here and you put it to ground anywhere in the airplane, you would hear this thing click, it would close. So that's what you're doing by running through these switches. You don't need any breakers for that because you're just grounding it. So that takes care of those two. Put your diodes from that terminal to the terminal side, the B or the battery terminal of the solenoid. It's marked BAT or battery on this side, so that's always going to be where the positive lead comes in from the battery to the terminal of the contactor. And the same with the other one, directly to the battery terminal of the other contactor. Add your diode from there to the grounding terminal, and then go from there to your switch and ground it when you want to energize it. The output side of the solenoids are tied together with a bus bar, a brass bus bar. And then, because they're going to always be together, as in you can power from this battery to this bus bar, or you can power from this battery to this bus bar when you close the contactor in here, or you can put both batteries on and it powers the same bus bar. So the output side, as is also shown in on the wire diagram, ends up at the same place and powers the same thing, the whole airplane. From that bus bar, you want to get a wire over to your main power bus, this guy here, that powers all the various things in the airplane. Now, the airplane one is different than the engine one. Okay, this is a designated one for the engine, and the same with the grounding bus. You want one for the engine. So very quickly, you know, we're seeing here that we've got power for our one fuel pump and another fuel pump, various things, just like the wire diagram shows. Here's where you would get power to those things that are shown on the wire diagram. The same with this grounding bus. This is where you would ground the things that are shown on the wire diagram. Then, in addition to this number 10 wire that powers up this bus off the output of the main contactors, you need to have a heavy cable running to the starter. It's hard to see here, but that's from this terminal, since these are tied together with a brass bar. Then from there, there's a cable running back here. These are the two ground cables right here, but there's another one that's protected in a loom back here that runs through the firewall and all the way to the starter. The reason that it is protected with this loom is because it's a hot wire, and if it ever were to chafe onto metal, it would make a giant spark. So it needs to be protected the whole way to the starter, and also from the starter down to the alternator. On the grounding side, it's very similar. As you can tell, there's a brass bar across here, and that just makes the two batteries kind of tie them together, and gives us, you can drill as many holes in the brass bar as you want to add other features, other ground, main grounds. You know, you don't want to use this for the little grounds, but here we got a number 10 cable running down to our grounding bus, and we ground everything there, just like we did with the positive, and we have all our positive outputs over here. This just happens to be an avionics junction thing here for this particular airplane. As you can see, there's two ground cables going into this brass connector bus. They both go to the engine. They go to two separate locations on the engine, and that's to have redundancy. They end up in the same place, but you want redundancy in your grounds because of the engine requiring electrical power to operate. Those are not as critical as far as chafing protection, because if they ever were to touch metal, that's also ground. What you're seeing in the back here is the Viking ECU. That's the control unit that runs the engine, operates the fuel injectors and so forth. And it is mounted here on rubber feet. It also has a little two-sided tape rubber piece in the front and back here to keep it from tipping on the feet. The connectors are self-locking. I think we showed this already, but you have to kind of bring that up and then it'll pull out. And when you install it, make sure that you can hear an audible click, and make sure that the connector is all the way in. And then you are going to wire the cables that come out of the connectors as shown earlier. Physically wire them to the airframe. Now, as far as instrumentation of the Viking engine, in progress right now, and we're at the beginning of, or halfway through 2016, there's a new version of what we've been referring to as a Viking View instrument that runs off of a CAN bus system, meaning the 9-pin connector that comes from the computer can be used to plug into the back of an instrument, an LCD nicely backlit display that will provide information directly from the engine computer to the pilot on an LCD display. And this will be available somewhere around August of 2016. And it makes a fairly revolutionary way for you to be able to just plug one wire in and then have engine related data available in the cockpit. And you're looking for the parameters, which would be like your oil temperature. It's not critical with the Viking. In fact, there's even no oil cooler, but it should be below 240 degrees on the oil temperature. Your gearbox temperature should run around 180 to 200 degrees. That's normal operating temperature for the gearbox. Of course, the gearbox can be air cooled. If the gearbox temperature is running hotter than that, you can provide holes in the cowling in the front and have the engine propeller or the propeller blow air directly on the gearbox, because it doesn't have hot oil from the engine, it has its own oil, so you just cool it with air if you need to. The coolant of the engine should stay 180 to 210, thereabouts, is normal. If it occasionally goes to 230, that's not a big deal, but that's your upper limit, and you want to then just increase the intake size of the airflow going to the radiator, and maybe close the air gaps where air is escaping from the radiator a little bit better. So you want to focus on your 100% focusing on getting air through the radiator, and no focus on trying to cool the engine by blowing air onto the engine, because it just doesn't work that way with a liquid cool engine. The radiator is super efficient transfer media to draw the air out of the Evans coolant through the very small passages. So you want to put all your effort into getting all of the air through the radiator. The other place you want to get quite a bit of cold air, and you want to cut and get from the shopping cart a NACA inlet for the top of the cowling, and you want to blow cool air onto the air cleaner as much as possible. The cooler air you can get on the air cleaner, the more power the engine will produce. Other parameters would be oil pressure. The 130 engine has a variable output oil pump, so it's not uncommon to see low pressure at idle, around 15 to 25. But then as soon as you increase the RPM, the pressure will go between 40 and 70 is a normal range for oil pressure.
Someone was asking on the forum what the easiest way to remove reticle clamps are. The easiest way is just to get a pair of skinny diagonal pliers, go underneath the area where the clamps overlap, and peel the clamp off of the assembly. No swearing required.
This is an area on an engine where the gearbox is not put in place. But we're showing this because it's a little easier on the movie. This is a NPT, an 1/8-inch NPT plug. Most all sensors that sense temperature that are used on various instrumentation that you can buy will use an 1/8-inch NPT thread. Now, if you use an Allen wrench coming in next to the gearbox here with a ball socket, you can take this plug out and you can get your temperature probe to screw in there. It's a little bit tight, but we've done it on a few installations and it is possible. So it's a little inconvenient, but it can be done, and it is the perfect location to pick up the right temperature as it exits the engine right here. This other one, by the way, is for the computer, and it sends information to the computer to run the engine. Now, if you do use the new upcoming Viking View, you don't need a sensor here, because the information that's fed to the computer, it goes through the 9-pin DBA connector that is supplied with the harness, and that plugs right into the instrument. So it uses the original sensors rather than adding another set of sensors on top of that. This engine being kind of stripped down, we can look over here too. This is an area that was kind of hard to see because it's underneath the manifold. This is how the engine is shipped, and this is plugged off with an reticle clamp. This is where you would either put you could put a hose right on here and go to your heater, or you can put a 90-degree fitting in here, which you can buy at auto parts store. They call a heater 90-degree heater fitting. They come straight, they come 90s, they come 45s. They're usually a glass-filled nylon. And you could then go 90 this way and come to your heater, or you could go 90 and sneak the hose out this way through your firewall for your heater. Here's that bypass hose we talked about that comes from here, and it just goes to the thermostat down here. Here's the solenoid for the variable valve lift of the engine. We talked about some of that in the wire when we showed the wire harness. This is the cam sensor pickup right here. The crank sensor pickup is on the other side on the bottom, right underneath this cover. This is your fuel pressure control solenoid directly on the pump. We've got some things back here. This one doesn't have it on yet, but right here is where your variable valve lift solenoid mechanism would go. These are your engine mount locations for the 2 upper engine mounts and the 2 lower engine mounts. This engine mount also has some clamps here in order to hold some wiring in place. Your starter will be sitting right in here. Here's where you would come in with your cabling. Here's the oil separator plate that's behind the starter. There was, remember we talked about a hose going from here and it goes underneath here and it exits down here. Very little, if no oil ever comes out of it, so you don't have to be too worried about blow-by of this engine. We also had the other side we talked about a little bit, which was the exit for the oil separator that's built into this cover. And we usually run a hose from this and put a couple of clamps in here. This, by the way, is for nothing. This goes right through the cylinder head. Everybody asks why there's a hole there. Well, it goes right through because it's in the Honda car, it's used for exhaust gases to just flow through here, and then this intake manifold goes over that, and it's for EGR, or exhaust gas recirculation. So it's not used for anything. In fact, it can be used with a heavy rope or strap going through it to hoist the engine. Just be careful with this sharp edge that it doesn't cut it. This area, by the way, behind the gearbox, is where your locator ring is. This is a Teflon locator ring, and it's very important that if you ever remove the gearbox for any reason, for maintenance or any kind of an upgrade, that you replace this every single time. The reason being that in order for the gearbox to have a perfect center where it matters the most, which is right here in the center, there are no locating dowels out here. The gearbox is placed on here with its spacers, and the bottom gear has a protrusion that sticks into the locator, and that's what centers it. And then you tighten all these bolts incrementally until the whole gearbox is flush with the bell housing. Then you back them off just enough that everything is loose, but it is up against it, and then you retighten it, and it'll be perfectly centered here. Now, if you don't replace this every time, then if this has any kind of wear in it, the gearbox will not be centered, which of course is not good with the kind of RPM that we're running. So yeah, replace it every single time. Now, one more thing I'd like to mention. These engines are all shipped out, as you see them here, with all the cast protrusions on them. In some installations, these ears are used to mount the engine in, for instance, like say a gyrocopter, so forth and so on. In other installations, the cowling might interfere, maybe not on this one, but because it's closer to the center of the engine. But this ear might, for instance, in a Zenith, will interfere with the cowling. And if the ear is not removed here at Viking, and you're installing it in an airplane where you obviously can see that the cowling would hit this, you just cut this off with the appropriate tool. This is a summary of how to install an airplane engine in an aircraft. What you will receive from Viking is an engine that's all put together. You will also get an engine mount and a cowling. So basically the steps are, for anyone that's familiar with an engine installation, and what we would do here at Viking if we were to install your engine for you, we would take the engine mount and bolt it to the firewall. We would hoist the engine, and we would take our engine mounting hardware and we would bolt the engine to the engine mount. We would consider a few things, like we have fuel and electric basically, and cooling. So we would mount the radiator and hook up some hoses and fill the system, and that would take care of the cooling. We would mount a couple of batteries, mount the computer, run the wire loom, and put power to everything. We would mount a couple of fuel pumps, get fuel to them, put some switches, turn them on and off, and some breakers, and that's the fuel system. We put a bottom cowling and a top cowling, get it all fitted, sanded, put some fasteners on, put a propeller and a spinner on, and go flying. So all the details are, there's lots of details, but basically that's what you're going to be doing. Hoisting, mounting, fuel, electric, batteries, get some power to the computer, get a starter key, start it up, taxi out, and fly it. And we're going to do some videos later on that exact thing, starting the engine, taxi, flying here in Florida, showing you a little bit about operating the Viking engine. Thanks for watching.
So this is how you would get to our Viking shopping cart. What you would do is go to our main website and then scroll down and go to the Viking store. Once you get to the Viking store, you will find everything that you would need for the Viking engine. On the left-hand side, you will see all of the different options you can go to. Here's where we would have our Viking engines. Now, with the Viking installation parts, this is everything you would need for your firewall forward. So you could just scroll down and find absolutely everything you'd need to install your Viking engine. When you go over here to engine mounts, you can find all of the prices and list of the engine mounts. If you click on cowlings, you can find cowlings. For propellers and spinners, this is the propeller installation. You would find the propeller extensions, the balancer, the spinner, and the different propeller options that we have. For installation help, you would find our installation service. For service parts, you would find the items that we carry to help you service your engine. Also, updated parts and improvements. You can click the Viking shirts and decals to get some Viking merchandise. To find plane-specific parts also, you would find them on this side of the screen for the RV-12 and Zenith parts. And if you just need to make a payment towards Viking, you just have to go to the Make a Payment selection. Please note that this is not our main website. To get back, all you would have to do is click the other screen and you're back at home. All right, so let's talk about the Viking forum. From our main website, you would click Join the Viking forum if you're not already a member. So you would enter your email address and password here, and then you would also type in the CAPTCHA of what this picture is. And if you're already a member, you would go to sign in to Viking Aircraft Engine Forum. This is the home page where you can just scroll down and see the most recent posts. The Viking Aircraft Engine Forum is where we handle a lot of our technical support as a community. You can find other people who are building the same aircraft as you. You can view photos and videos and installation help. To go to installation, here you'll see all of the different installation videos that we would provide. And if you go to photos, we post hundreds of photos, both of the airframes, and you can post photos in them as well. For example, if you were to click on this Xena 750, you could see photos of other people who are installing their Viking engine into a Zenith 750. To go to a specific topic, you would go to forums and then scroll down and find what you're looking for. Viking Aircraft posts hundreds of videos. This forum is designed to where you can make friends and add them for people who are building the same airframe as you. So you can also go here to invite your friends as well. That's it.